I welcome you all for engage your learning experience with pantechelearning anytime, anywhere, at any places. We are always supporting to the student in a technical way, and our main vision to help 10 million students easily learn the technology. So today is day 18 on 21 days masterclass series on autonomous vehicle. Today we are going to discuss about one example. So in this example, we will explore how to create a dynamic driving scenario using the MATLAB driving scenario designer app. So specifically, we will focus on designing a scenario where vehicles executes a 3-point turn while moving in a reverse direction. So listen carefully, we will focus on designing a scenario where the vehicle executes a 3-point turn while moving in a reverse direction. So this example, it provides a practical experience of a vehicle maneuvering and vehicle control app. Through this driving scenario app, you will learn to set up the virtual environments and configuring the vehicle properties and defining the path and sequence maneuvers. So by simulating the scenario, they can observe how the vehicle dynamic play out in a various driving situations and enhancing their understanding of the real world driving challenges. So this example, it gives you a hands-on experience to explore the concept related to the vehicle motion, then related to the maneuvering strategies and scenario simulations like that. So first of all, let me discuss about what is the 3-point turn scenario. So in driving, these mastering maneuvers such as the 3-point turn is a very essential for navigating the various road situations. So here a 3-point turn is also known as a Y turn or a K turn. So this turn, it allows a vehicle to change its direction on a narrow road or in a situation where making a U-turn is impractical. At the time we use this 3-point turn scenario. So first, this scenario, it involves the 3 distinct segments. So 3 segments, each serving some specific purpose. So first one is the forward turn. So first segment, forward turn. So this is a drive forward and turn toward the opposite side of the road. So this vehicle, it starts by moving forward and turns toward the opposite side of the road. So this is the initial movement positions. The vehicle for the subsequent reverse manner, this is a very initial movement. And next one is the second segment, that is a reverse turn. So next, the vehicle transition into the reverse mode or a reverse motion while turning back toward the original side of the road. So this segment, it requires a careful coordination to the maneuver the vehicle's safety in reverse mode. So next is the third segment. So what is this third segment? It's like a forward completion. So finally the vehicle moves forward again, completing the change in a direction and aligning itself with the desired travel path. So by executing these 3 segments effectively, the drivers can navigate the tight spaces or adjust their route direction without a need for the extensive maneuvers. So the 3-point turn enhances the driver's awareness and also the driver control and driver's decision making skills, and that contributing to the safer and more efficient driving practices. So throughout this example, the drivers can develop a deeper understanding of the vehicle dynamic and also the maneuvering strategies. So that is why this is a very important example to discuss. So where we use this concept in a self-driving or a autonomous vehicle applications. So adapting these 3-point turn scenario, especially for the autonomous vehicles or a self-driving cars, it involves some manual driving actions into the automated task so that the vehicle's control system can execute. So I will tell you how this scenario that can be utilized for the autonomous vehicle. First one is the planning and perception. So the autonomous vehicle perception system, it detects any obstacles or any road markings or any other relevant features to determine a safe location for executing the 3-point turn. And next one is the route planning. So based on the perception data, the vehicle's destination and also the autonomous driving system, it plans a route that includes a 3-point turn maneuver where necessary. And this route planning algorithm, it identifies the suitable locations for the turn and considering the factors road width or traffic conditions and the legal constraints like that. So this is what the route planning. So next one is the maneuver execution. This autonomous vehicle executes the 3 segments of the turn autonomously. So following the predefined algorithm. So for the first segment, the vehicle navigates forward and turns toward the opposite side of the road. So this will ensuring it positions itself appropriately for the reverse maneuver. And next one is the second segment as we discussed earlier, the 3 segments. So now the second segment. So the vehicle transition into the reverse motion while turning backward toward the original side of the road. So this autonomous control system, it ensures smooth and safe reverse movement considering the surrounding vehicles and also the any obstacles. So finally, the vehicle completes a turn by moving the forward again and aligning itself with the desired travel path. So next is the sensor fusion and control. Throughout this maneuver, the autonomous vehicle's control system, it integrates the data from the various sensors such as the camera, radar and lidar and GPS to accurately perceive the environment, perceive its surroundings, that making a real-time adjustment. So we use this advanced control algorithm. It governs it measures the vehicle's acceleration and also the steering and braking actions and maintaining the precise trajectory, speed waypoints and vehicle stability. So the autonomous driving system continuously monitors the environment for the potential hazards or also the dynamically adjust the vehicle's behavior to ensure the safety. So in situations where the unexpected obstacles or any changes occur, the vehicles needs to take a decision. This vehicle's decision making algorithms may reevaluate the planned route or adjust the maneuver accordingly to avoid any collisions or any disruptions. So by implementing these 3-point turn scenario in autonomous vehicles, so developers can validate and refine the vehicle's capability. So executing a complex maneuvers autonomously. So this example, it helps us to enhance the vehicle's navigation side and vehicle's perception and vehicle's control algorithm that contributing to the advancement of the autonomous driving technology. And also it improving overall road and safety efficiency also. So you can use these reverse motions to design more complex scenario, especially for testing the autonomous driving algorithm. So for that, we are going to use a MATLAB driving scenario app. So just a minute. So these are the steps. So first you have to open your MATLAB driving scenario designer app. For that app, we are going to use the MATLAB command prompt or else you have to choose directly on that app section. So I am going to open the MATLAB software. So before we will discuss about the steps. So what are the steps? First you have to add the road and then you have to add the lane and then you have to add the trajectory for that vehicles. So first you have to add the road. For that we are going to open the driving scenario designer app. So there are 2 ways while we are going to open this app. So directly you go to this app section. So under this app section you will get it your app. So it will take time. So directly you can type the driving scenario designer or else you can choose app section and go to this section. Scroll down here, you can see the automotive section. Under this automotive section, you have to open the driving scenario designer app. So first we have to add a straight road to that scenario. Just a minute, it will take time. First we have to add a straight road to the scenario. So for that, inside this driving scenario designer app, right click the scenario canvas and select the add road and extend the road toward the top of the canvas until it's about the 50 meters long. And then double click to commit the road to the canvas. Just a minute, it will take time. So this is our driving scenario designer app. Inside this app, we are going to do this reverse direction. And this is the scenario canvas and this is the app tool strip. So I am going to add a straight road into the scenario. So for that, right click on the scenario canvas. Right click on the scenario canvas. Here you can see the add road. Please select the add road. And here I am going to create road. It's a 50 meters long. So 0 to, just a minute, 0 to just a minute. So I am going to add a road here. So just that's a 50-meter long. So 0 to 15 meters or else 60 meters. Whatever you want, you have to create. So press the enter or double click the cursor. Here you can see this is our road. So now I am going to increase the width of the road. So in the left side, here you can see the width of the road. I am going to change the width of the road to 8. So it will increase. The width is increased. Now I am going to add the lane. Yeah. So without lane also we can do this one. So I am going to add the vehicle. Now for that, go to the app tool strips or right click the bottom right corner of the road. So right click the bottom right corner of the road. And here you can see the add car here. So zoom in on the vehicle, the first half of the road. So which is where the vehicle will execute the 3-point turn. So here we will execute the 3-point turn. So now I am going to execute that one. So for that we are going to add a trajectory. So that means we specify the trajectory for the vehicle to complete the 3-point turn. So for that, right click the vehicle and select the add forward point. So here I am going to zoom on this one. I am going to zoom on this one. Just a minute. Yeah. So right click the actor and here you can see the forward waypoints. So from this forward waypoints, we have to specify the first segment of the 3-point turn and click to the add waypoints that turn toward the left side of the road. So I am going to create add the forward waypoints here. So just this is the first turn point. I am going to create that one. So listen carefully. Yeah. So this is my forward motion. Now I am going to press the Ctrl R. So here you can see this is the reverse motion. So this is the reverse motion. Now I am going to do the reverse motion. So specify the second segment of the 3-point turn. Press the Ctrl R to switch the specifying reverse points. So then click to the add waypoints and that turn back toward the right side of the road. So now I am going to draw that one here. So this is the right side of the road. So here I am going to draw this one. So just give the randomly, this is the second reverse motion. So now we are going to specify the third segment of the 3-point turn. So for that, press the Ctrl F to switch back to the specifying forward waypoint. So I am going to switch back to the Ctrl F, that is the forward waypoints. Then click to add the waypoints that turn back towards the left side of the road and adjacent for the first specified waypoint. So here I am going to do that one. So this is my reverse motion and again we are going to press the Ctrl F. This is the forward motion. So from this I am going to give my waypoints here. So just a minute, I am going to give my waypoints here. So this is my waypoints. So 1, this is the 2 and 3 and 4 and finally 5. So this is my forward motion. So press the enter. So press the enter to commit the waypoints to the canvas. So the successfully we created that waypoints. Now we are going to run the simulation. So first to view the direction that the car is traveling. So for that go to this display. Go to this display option and here you can see the show actor pose indicator during the simulation. So as the simulation runs in the sense the vehicle briefly stop between the each point in the 3-point turn. So when the switching is between the forward and reverse motion in a trajectory, so this app it automatically sets the velocity value. So sets the velocity value at the waypoint where the switching occurs to the 0. So it's I will give you in a simple I will explain in a simple manner. So when a vehicle transition between the forward and reverse motions, especially in a scenarios like a 3-point turn. So that means the first segment, third segment, second segment. So where the vehicle must change the direction quickly. So it's a very crucial to ensure a smooth transition. So we know that is a abrupt continuous changes in a velocity that can lead to unstable behavior of the vehicle. So both in the simulation also and the real world scenario also. So by stopping the vehicle at the switch point, the simulation allows for a smoother transition between the forward and reverse motions. So this brief that pause helps to any sudden changes in the velocity that resulting in a more realistic uncontrolled maneuver. So that is why we do that one. So in a real world driving scenario, the safety is a main thing. So when a vehicle changes the direction, it is a very essential to ensure that the maneuver can be executed safely without without any the occupants of the vehicle or any other roads on the road. So stopping the vehicle momentarily before changing the direction that provides an opportunity for the autonomous driving system to assess the surrounding environment. So it can check for the presence of the other vehicles also, other vehicles or any pedestrians or any obstacles. So that may impact the maneuver. So in the simulation environment, this trajectory planning and this control algorithm, it plays a very crucial role in determining the vehicle's movements. And also these algorithms calculate the vehicle's trajectory based on the various factors such as its current position or a velocity or any desired path. So when the vehicle reaches the switch point in the sense between the forward and reverse motion, this planning algorithm, this waypoint planning, this trajectory planning algorithm adjusts the vehicle's velocity accordingly. So by setting the velocity to 0 at this point in the sense, this algorithm, this ensures the vehicle follows the well-defined controlled path, controlled waypoint during the maneuver. So this helps to maintain the stability and accuracy in the vehicle's movements throughout the simulation. So that is why we change that one. So by setting the velocity to 0 at the switching point in that simulation, so it's a one kind of the choice made to ensure a smooth, safe and controlled transition between the forward and reverse motion. So now I am going to adjust the trajectory by using the specified yaw values to fine tune the trajectory. So to fine tune so what are the trajectory here? So we trajectory in the sense, so expand this box. So this column, you will see your trajectory. Yeah, so this is a waypoints and speed and wait times and yaw angle. So to fine tune the trajectory, it specifies the yaw orientation angles for the vehicle to reach the specific waypoints. So for example, the vehicle begins its reverse motion trajectory. Suppose we want the vehicle to be exactly at a 90 degree. So 90-degree angle from where it started. So now I am going to first determine the ID of the waypoint. So where the vehicle begins the reverse motion. So here we will begin the reverse motion. Here we have the reverse motion. So reverse motion by moving your pointer over that waypoint. So moving your pointer, moving your cursor over that point. So what is a waypoint here? That is a waypoint 5. So then the waypoints and speed and wait times in the yaw table in the left plane of the driving scenario app. So I am going to change the yaw value, that is the degree value, to the corresponding row. So going to the fifth waypoints. So here what is our yaw angle? So 60 degree. Now manually I am going to change this angle to 90 degree. So for example, if the vehicle begin, it's a reverse motion at a waypoint 5. So I am going to update the fifth row of the yaw angle, that is a 90 degree. So during the simulation, the vehicle is now tuned exactly the 90 degrees from where it began. So to clear a previously set value, so we want to clear that previously set value. So go to this right click the waypoint here. Here you can see the restore the default value. So you can also clear all the set values by the right clicking the scenario canvas and selecting the restore default value. So why we do this in the sense, the first step is to identify the specific waypoint where the vehicle starts its reverse motion. So in this driving scenario designer app, each waypoint along the vehicle's path that is identified as a unique identifier or a ID. So by moving or by point outing the waypoint where the reverse motion begins in the sense, the user can determine the IDs. So that is a waypoint 5. Waypoint 5 is the ID name. So this allows for a precise targeting the waypoint for the subsequent adjustment. So I am going to setting the orientation value. That means yaw angle value. So once the ID of the starting point of the reverse motion is determined in the sense, next we have to set the value of that, set the degree of that yaw angle. So that is why we do that one. So setting the yaw angle as a 90 degree, it indicates a change in the orientation, change in the direction. So this typically it representing the right angle turn for the vehicle. And this adjustment, it aligns the vehicle's orientation with the desired direction of the travel for the reverse motion segment of the 3-point turn maneuver. So this is the way you are going to create your reverse motion by using the 3-turn scenario. So just a minute, I am going to run the simulation now. Yeah. So here you can see we specifies the 90 degree of the yaw angle. So at that time our ego vehicle will be start from that one. Yeah. So this is the way you are going to create your own reverse motion by using this 3 steps. By using this 3, what is this? By using this 3-point turn scenario. Again, I will show the output. Yeah. So listen here. Listen carefully. So this example is focused on creating a simulation for a 3-point turn maneuver using the driving scenario designer app in a MATLAB. So this maneuver, it involves the 3 segments. One is the forward and reverse and forward completion. So again, I will explain you. So this is the forward. So this is the forward and this is the reverse turn. So this is the reverse turn and again we will conclude the forward completion. So you can analyze the how to create this scenario and adding the vehicles and configuring the vehicle properties and defining the path also and also sequencing the maneuvers within that app. So this entire simulation scenario is aimed to demonstrate the vehicle's ability to execute the 3-point turn autonomously. So we have explored that process of adapting the manual driving actions into the automated task for the autonomous vehicle. So by simulating these 3-point turn scenario, you will gain information about the complexity of the autonomous vehicle maneuvering and control. So that is why we have learned today. So this is all about today's session. Thank you all.